Okay, so this is part 7. I did a video on confidence intervals just recently, and I wanted to expand on it for a minute. So here we're looking at the 95, and I'm going to make this a Z table. We're looking at with the 95% confidence using, let's assume 40 samples. So we could use the Z table. Remember, whenever you're over 30 and you assume a normal distribution, you could use a Z table. We'll talk about T tables in another video, but the mean in this case is we're going to use 162 degrees Fahrenheit. And the standard deviation that we're going to assume is 10, or we have in our sample is 10. So we have all of our information here. Within 95% confidence, using 40 samples. And remember, what we're doing is continually taking samples and trying to give the audience or the end user confidence in it. So it's like when you're watching an election and they say so-and-so is going to win this state or win this county or whatever, this election, with a confidence interval of plus or minus, like say 3%. Well, this is what they're doing. They're measuring all these different samples that they take. They're coming up with an average return or an average outcome, and then they're using a standard deviation, which is the dispersion, as you recall, of the data from the center or the mean. And then by using a Z table, we can come up with a margin of error. And how we come up with that margin of error, once again, is we take the standard deviation divided by the square root of the samples. So if we raise the samples, and then well, just to continue, then we come up with a Z value, and the margin of error is what we get out of our Z value times this standard error. But notice that when we raise the number of samples, the error diminishes, because the mathematics behind this equation, which you don't have to get that deep into it, is with more samples of each sample, and with more samples of each sample estimate, we could lower our margin of error if we take more samples. Now, so if I go down to, let's say, 10 samples, notice that the margin of error is much bigger. So that gives you really what we're looking at. It's the adjustment for the number of samples. But let's go back to the original 40 samples. And now we have a margin of error of 3.09. And once, because that's a function of our Z value times our error, the standard deviations times our error. So now we're coming up with a margin of error. And when we add or subtract it from the mean, we're getting our upper and lower limit. It's just basically what we're doing. So our margin of error is derived from our Z value times the number of samples divided by, the standard deviation divided by the square root of the number of samples. More samples, better estimate. So how would we use this in the practical sense? Well, let's say, for instance, I was, and another thing. Well, I want to show you something. If I lower my confidence interval, if I want to be 90% certain, this is the last part I wanted to show you. Yeah, I'm sorry. If I want to be 90% certain, well, then my limits widen. Watch what happens. It's 159 to 164. But if I go back to the 95%, right, at 95% confidence, I have a wider limit. At 90% confidence, I'm sorry, we have a tighter limit. If you wanted a 99% confidence interval, then I have 157 to 166, much wider. But if you want an 80% confidence, notice I have much tighter 159 to 164. So the lower confidence results in a tighter limit, because when I want a much more stringent limit, 159 to 164. When I want a more stringent limit, I've got a wider lower and upper limit, 157 to 166. So once again, before I explain this, at 99%, I would give my audience that within somewhere between 157.9, which is about 158 and 166, I'm 99% confident that my samples will come out to this mean and standard deviation. But if you only want 80% confidence, if you don't need to be that certain, then I can give you a tighter estimate of 159.9, which is 160 and 164. So once again, 80% 159 to 164, 99% 157 to 166. So it's wider as I ask, as my users ask for more confidence. So what does that mean in the real world? What it means is this. If you were coming to my house, and I'm doing this during Thanksgiving. So if you were coming to my house for Thanksgiving dinner, and you said, Ed, what time will we serving dinner? And I said, 3 o'clock. And you said, well, tell me within, because this is really important, I have other appointments, within 99%, give me a confidence interval, when it could possibly start, when it could possibly end. Well, then if it's within that kind of limit, I might say it's from anywhere from 245 to 315. If you give me that much room, I can come in with on most times I have this dinner, which is every year, I'm coming in at around 3 o'clock. But you have to give me a variation of anywhere from 245 to 315. But if you say, well, I'm really not that tight on time and I can live with an 80% prediction. Well, if it's an 80% prediction, then I could say it's anywhere from 255 to 305 because you're asking me, what you're doing is you're not asking me to be as stringent. You're not asking me to be as stringent. So I could be, I can give you a tighter estimate because I'm only 80% confident that will come within that range. And you understand that 20% of the time, it's just not going to happen. Whereas if you want a 99% estimate, I have to give you a much wider range because basically what I'm representing to you is that using statistics, and remember, statistics is always tricky, where that's the one caveat here, but using statistics, I'm going to only be wrong 1 out of 100 times. So I need to give you a wider estimate, I need to give myself more room for error. So I hope that explains it. That's really how you do the confidence intervals. And we're going to move on now to the next subject. But this kind of gives you an idea when we do regressions, and the regression gives us a z-value or a what we call a p-value with upper and lower limits. Now you're starting to get the idea of where we find these things. So remember this for when we do regression.